Hello, everyone. This is Dr. Shane, one of the Chemistry 126 and also Chemistry 122 instructors. And this is a tutorial to go along with the spreadsheet and graphing activities for Chemistry 126. And this is something that you'll do as part of the first couple of weeks as we're doing some online virtual instruction before we come back face to face. Health reasons, I think it'll make a lot of sense. And then when you come back for week 3 or 4, I forget what it is, we can hit the ground running. So I'm not going to review everything here. So you have some first semester Gen Chem problems, take care of stoichiometry, units, things like that. And then there's 4 spreadsheet activities that are also described on that separate handout. So if you're really good at spreadsheets, you probably don't need much of a tutorial. If you haven't used spreadsheets to do a lot of things, then this will be very helpful. And this is not a super polished tutorial. I'm not telling you exactly what to do. In fact, I find students are sometimes better at spreadsheets than I am, and that's perfectly fine. So there may be shortcuts that you know that are more efficient than what I'm about to show you, and that's fine. Okay, so follow the handout. The handout tells you exactly what the end result of this should be. So you'll probably end up submitting a document with handwritten work and maybe some typed explanations about the graphs. And then the spreadsheet, it's the worksheets. Well, the whole thing is a spreadsheet. The subsets are worksheets. I guess that's the vocabulary. And we'll go from there. Okay, so so this is not going to be the most polished thing you've ever seen in your life. So I'm going to share the screen. And I think this will work. There, I think we're sharing. And we probably don't need the video at this point. So I'm going to actually stop the video and go back to sharing the screen. And there's my background. That's very exciting. Okay, so hopefully this is recording at this point, and we'll just kind of see how things go. Okay. All right, so you are generating 4 graphs, and one of the first things you're going to do is you're given some data here, and absorbance versus concentration. I think that's what we're trying to do. Yeah, so if you look at the handout, basically what we're trying to do is generate a graph, and I have a little stylus here, and we want to put absorbance on the y-axis and concentration on the x-axis, and it should be linear. Something like this. So I'm not giving you everything here. You want axis labels and units on here. You want a title. You want things spread out so there's minimal amount of dead space, either above and below the graph or side to side. So we'll talk about how to do that. You don't want to have dead space on a graph. Okay, so to make a graph, Excel, that's what this is Microsoft Excel. Microsoft Excel calls this a chart. So you go under Insert, and you'll see insert charts, and there's all kinds of options here. And the main one you're going to want is this one where it says, and it gives you a bunch of options here, but we need to tell it what data we're doing. So the nice thing about Excel is, yeah, there's a way you could type in the range of the Y data and the range of the X data manually, if you will. But this one allows you to, just going to get back up here, is you just kind of grab the data. So there, I'm just grabbing all of the data, highlighting it. I'm not highlighting the column headings that have the axis labels. That's not really what we want. And then, you know, you could, I guess you could do a pie chart if you wanted to, but that would look kind of dumb. Okay, that would be stupid. All right, so we're not doing a pie chart. We want to see where the points are. How much of a line is this? And there's different ways to do that. So there we go. There's, whoa, we don't want that because that's connect the dots. That's also connect the dots. That's connect the dots without using points for the X, Y. What you want is that. That doesn't look too linear, does it? Well, that's okay. This is real data. So we're gonna do a best fit line through that. That's like if you took a ruler and tried to draw the best fit line, but we'll use the algorithm here. So boom. So there we go. I just graphed the data. Here's the problem. Take a look at the values on the x-axis and the y-axis. It actually has them reversed. So it has 0 to 6 on the y-axis. Well, that's the concentration. It has 0 to 1.2 on the x-axis. Those are the absorbances. I didn't graph it right. So it looks like we have to, when we grab data, we have to grab it in the order of, we have to put the X data first and then the Y data. Well, that's kind of a pain. And you might know a secret to doing this. Maybe there's a button you can click that reverses the axes. I don't know. I'm not gonna bother with that. I want to show you some basic spreadsheet skills. So I don't want that graph. I want to flip-flop these columns. And there's different ways to do it. That's fine. One thing I'm going to do is you can just highlight. So we want to basically put column A on the other side of B. So I'm going to highlight that and just use the Control C, or well, actually not Control. I don't want to copy it. I want to cut it. So that's Control X, or you can just use the cut and copy functions up here. I think keystrokes are easier. Come over here and then paste it. And it's kind of a pain because it uses the same column width. There's a way to change that, which I'll show you later. And so I'm going to grab the top of the column C and make it a little, okay, good. So I just switched the order of the data, but now I have this empty column over here that looks just kind of bad. So I'm gonna highlight that whole column, and then you can actually use your right click on your mouse, or just select delete, and then it'll move everything over. Actually, okay, that's fine. So now I think we're good. So now you can highlight the data again. Okay, and then go under, where is it again? Insert, charts. And now we'll pick the one with just the data points. I think that's right. I think that's right. So it looks like our y-axis goes from 0 to 1.2. That looks like the absorbances. And it goes from 0, which makes sense, up to 6. Also, 0, 0 kind of makes sense for this graph, because if, well, I'll let you, actually that's a question on the handout. Why should the absorbance be 0 at concentration of 0? Maybe it's so easy it's hard. Okay, so it doesn't look like we have to rescale these axes, but there's a couple things I want to show you here. If you can change the title, you don't want to just call it chart title. You probably want to call this standard curve or something. You just click on it and change it, highlight it and change it. But you don't see any axis label. So there's different ways and you'll get better at this. So click on this plus sign over here, and it gives you can add axis labels, axis titles, boom. And you can click on those and change those. And so you put the units in parentheses. I'm not going to do that for you. Excel calls a best fit line, they call that a trend line. So yeah, you can put the trend line in there if it's linear. Now actually, if you click on that, I think if you click on that, it gives you a bunch of options. Yeah, you can actually fit it to different things like linear, exponential, stuff like that. But this is we think this is a straight line. Fine. The other thing I want to show you here is the basics of, so at some point we're going to want to get the slope of this line because it's y equals mx plus b. B, the y-intercept, should in principle be 0, but I'll let you think about that. And I'm just going to put this in some random place. There's functions on Excel. A mathematical function is preceded by an equal sign, and we're going to use that a lot. And in this case, the mathematical function we want is slope. Cool, and it tells you. You start typing it in and the functions pop up. Returns the slope of the linear regression through the given data points. Awesome. What are the given data points? Well, put a left parenthesis and that will tell you, all right, now you have to pay very careful attention here. It wants the y data first and then the x data second, and it's separated by a comma. You can still click and drag and all that stuff. So the y data are absorbances. So I'm going to click B2 to B12. Now you can actually physically type B2 colon B12, and the data will actually highlight as you type that. You can try that, or click and drag. Then you put a comma, and then the function tells you it skips over in boldface to the known x's. So we click, we drag. Excellent. So B2 to B12 are the y data. A2 to A12 are the x data. And then we have to put a parenthesis after that. Then you hit there. It doesn't give you the units. It doesn't give you the proper significant figures. I might as well show you that now. We have never really discussed significant figures with doing a straight line, but I probably don't have to convince you. It looks like we'll probably have 1 or 2 sig figs on this. I'm not too concerned about sig figs this activity, but let me just do a couple things here. So maybe we should label what this is and just click above it and type in the word slope. Organize your spreadsheet better than this. Mine's pretty messy. And then if you want to change like this just gives you a bunch of numbers. If you want to format the cell, you go over here under format cells. This I think you can like double click on it too or something like that, and I'll try that later. And you click on number, and it'll tell you how many decimal places you want. So if we want, so this only starts, so if we want 2 sig figs, looks like we just want 2 decimal places. Click on OK, and it truncates it. Hopefully it rounds it. I didn't really look to see if it did that. And it rounds it. It doesn't give you the units. You have to figure out the units on your own. So that's the first graph, and that should give you, do all the other stuff that the assignment says. I'm not doing everything for you here. And I'm doing this kind of sloppy just to kind of make the point. All right, so that's the standard curve. The next one, we don't have to spend too much time on. The pH titration curve. Okay, so I'm not really concerned that you know what this is, but what we're doing is taking something that's a base, so it starts out with a pH that's above 7. If this doesn't make any sense to you, don't worry about it. And we're adding HCl to it, so the pH goes down, gets more acidic as we add more acid. And what we want to do is generate a pH titration curve, and the end result should look like this. So we want pH on the y-axis, so right away you might already see that the data in the order that it's given is wrong. So you have to highlight and rearrange the data. And if you have figured out a way just to highlight 2 columns and have them flip-flop one another, that's awesome. I think there's some way where you can just sort of grab the top of the column and drag it to its new location. I didn't bother to figure that out. You can do that. So you put pH there, and that, which has no units, by the way. There's no units on pH, and the volume of HCl. Oh yeah, and try to get used to doing stuff like subscripts up here. I think yeah. See, when I typed in this, it just says VHCl ml. You can highlight the HCl part, and then it's kind of hard to find. But under font, it'll let you do subscript. So start getting used to doing nice things like that to make it look better. Okay, so but that's kind of just an add-on, but subscripts and superscripts are kind of important in science and chemistry. And the graph should look like this. It'll come down, it'll level off, and then it'll come down. And the assignment tells you to identify what are called the equivalence points, which are the inflection points. Now, this is one of a math term. So the inflection point technically is when the curve switches from concave down to concave up, so somewhere like there. Concave down. This is sloppy. So they're going to be here. I'm not really worried about it. So you want to label these. This would be called the first equivalence point. This is called the second equivalence point. So you can label those: first equivalence point, second equivalence point. And there's ways you can do drawing. I forget exactly how it does it. You can let's see, insert. I'm not going to do it. You can actually figure this out yourself. You can insert text. You can make a text box if you want to give a little explanation or you want to label something. I think that's how you do it. Yeah, text box. Yeah, but you figure that out. There's actually ways you can do clip art and draw an arrow specifically to where you're pointing. But I'm going to leave that up to you. And you come see us if you need help. I don't want to make this tutorial 3 hours long. So that's the second one. And you're asked to I'm not sure if there's any other questions that go along with that or not. The third one is about as easy. It's called an absorption spectrum. What we're doing is we're changing the wavelength. Oops, sorry about that. My stylus is also a mouse. So another thing to get used to here is you can use Greek symbols in Word and Excel. So start getting used to that. So lambda, alpha, beta, gamma. Okay, well, lambda is Greek for L. So if you type in a lowercase l and you go under home and select your font, you'll want to choose, it's not really here. The font for the Greek letters is called symbol. So if you select symbol there, that'll take it from the regular alphabet that you're familiar with, the Arabic alphabet, I think that's what that is, and make it into the Greek. So get used to putting things, because why type the word wavelength? Just use the scientific symbol, okay? All right, this one you're making the graph. You're putting absorbance on the y-axis. Again, the data is not given to you in the proper order, but it's no problem. You just highlight, even though there's, how many data points? There's a lot here. There's, wow, okay, there's a lot of data. But it's no big deal. You just can click the top of the column and highlight the whole thing. Just bang, and then cut and paste and rearrange stuff. So if you find yourself holding and dragging a lot, you're probably doing something wrong. So here you're graphing absorbance, which also has no units, and then wavelength, you're given the units. And you'll get something that's kind of like a peak. And then you want to find what's called the wavelength of maximum absorption. So that's the point of maximum absorption. That's where lambda max will occur. That's what that's called. It's on the handout. And actually the specific value for that would be down here. It's the wavelength of maximum absorption. Okay, so make that graph, take out all the dead space, and actually I forgot to show you on the titration curve how to take away dead space. So what I'm going to do is I'm going to graph this data backwards. So I'm just grabbing the data. It's a lot of data. It's 84 data points. I'm going to, let's see, insert chart. Oh yeah, it kind of makes sense for this chart to do the smooth curve, because this should be what's called a sigmoidal curve. I think that's what, yeah, sigmoidal curve. So it kind of makes sense to have a smooth diagram through the data points. So I'm just going to leave it like that. But look here, look at all this dead space over here on this side. So what you can do to read, because look at, this does not make any sense to have 0, 0 be the origin. Well, that is the origin, but that does not make any sense for this data. So what you do, and this is backwards from what you're going to have, because take a look here. This is volume on the y-axis and pH on the x-axis, the exact opposite of what you're going to do. But for illustration purposes, just kind of go over where the data are and click, I think. Yeah. And then you get all kinds of options. So actually, that's not the one I want to format. That looks pretty good, actually. The Y data looks pretty good. There's not a lot of dead space across the top or across the bottom. The problem is the data going along the x-axis. So I don't want to click that. I want to click on this. So the first pH is at 3 over here, right? And so it doesn't make any sense for the first pH to start at 0. So why don't we just change that to 3.0, and I guess the other side of the Y data looks fine. We can maybe change it to, I don't know, 11.8, but well, okay, let's just do it for argument's sake. So see what it did? It took away the dead space. And let's make this, will 11.5 get it all? Well, not 15, 11.5. Yeah, okay. So you can rescale this, but then make sure you go back and give it a title, click on the plus sign. You don't want a trend line here because it's not linear. And give it your click on your axes, titles, and do all that business. Okay, so I think we're done with the first 3. The last one is going to take a little bit. Okay, so the last one, here's the bottom line. This is a lot of stuff. Okay. This is the final sheet. So I'm giving you exactly what you should reproduce on your own spreadsheet, which I've given you a blank one down here. So yeah, okay, you could just cut and paste everything, but that's cheating, and we'll probably give you a quiz on spreadsheets. And oh, by the way, this is actually something you'll do very similar to this in lecture. The 3 graphs you're going to make are something you're going to do with your lecture professor. So if you understand it now, it'll make more sense later. So again, do it yourself. So first things first, let me show you. I'm going to kind of streamline this because the answers are given to you here, but I want to explain the chemistry, although I'm not too worried about it. The actual data is in blue. So this sample data. So you'll cut all of this data and put it onto a new worksheet. So let me just show you how to do that so you don't have to reformat the columns. So grab the sample data, everything in blue, go over, come down, don't cut it, copy it. So copy, gives you little ants walking around the perimeter. And come over here to sheet 2. Come up here and paste. Now, you can actually do this, you could paste, but if you do paste special and choose different ways, one of these ways keeps the source column widths, which is nice. There's other paste special, which are nice, that if you have a formula and you want to translate the formula so it doesn't change all your cell values, you can do that too. So paste special, there's a lot of nice things you can do with that will avoid frustration later. This is just one thing. So keep the source columns width, and boom, it keeps it like this. Okay, and then you can actually right click on the tab name, instead of calling it sheet 2 or whatever it is, rename it and give it, I don't know, so whatever you want to call it, like your work or something like that, just call it that. Right, so I'm going to go back to the final answer here and kind of walk you through what we're doing. All right, make sure you have the actual handout in front of you. There's a bunch of stuff I'm just going to write informally in this open space on the spreadsheet. So, here somewhere, and it may look a little sloppy. Hopefully I have enough space to do all of that. We'll find out. Okay, yeah, one thing I want to change real quick is the temperature is only listed as 1 sig fig. I want to add a decimal place to that, so you probably know how to do that by this point. So your thermometers can actually get 20.0. So, but when you type in 20.0, let me just show you. If you come up here and type in 20, I want it to be 20.0. But if it's 20, it just rounds it down, which is aggravating. So go under format cell, font number, and we want 1 decimal place. Good, and it'll put that 20.0 back. Okay, so here's the data. And we have to use a couple things here. This is the temperature. Now that's Celsius. We're gonna have to make that a Kelvin temperature by adding 273.15. This is a pressure in millimeters of mercury. We're gonna have to use the ideal gas law and do PV equals nRT. We're gonna have to convert that to atmospheres by dividing by 760. Excellent. The HCl that we're using in this has a molarity of 1.0, or whatever the bottle says when you do the lab down the line. And then you're gonna use 6 milliliters of that solution. Okay, and then you're going to dilute it to a total of 45. So we have to use the dilution equation, M1V1 equals M2V2 at some point. So we have to do a lot of chemistry calculations in these columns over here on the spreadsheet. And then, okay, so what data did we collect? Well, we collected all this data from the lab and from the reagents. But then what we did was we did a chemical reaction. And I'm not sure I'm gonna have space to write this, but hopefully you have it done by now. It's magnesium metal. I think it's magnesium. It's magnesium metal plus hydrochloric acid produces hydrogen gas and magnesium chloride. And I'm going to let you figure that out, that it's a 1-to-2 ratio between magnesium and hydrochloric acid. So I'm pretty sure it's Mg plus 2HCl goes to H2 plus MgCl2. I just gave you the answer there. So there's a 1-to-2 ratio in there somewhere that we're going to need. And I'm not going to go through all the details here. Then what we do is we do a chemical reaction where we mix the two together and we collect water, but that water is actually, every time you produce a milliliter of hydrogen gas, a milliliter of water is pushed out of a container. We'll show you how that works later. It's not important now. So we collect hydrogen gas. Fine, so these are all volumes of hydrogen gas. The first thing we want to do, and this is going to look kind of complicated. Wow, look at that. Is, N is moles. and then we can put H2 and put that as a subscript. We're calculating, we're going to take each of those volumes and convert them into moles using PV equals nRT. So moles is going to equal R, whoops, that's wrong, PV over RT. Now, what I have here, so is that right? Yeah, pressure times volume over R. Now, what I have here is what's in the formula. Oops, I guess I can't do that. Is what I have in the formula up here at the top. Now, it's probably not surprising. If I have no volume of gas, the number of moles is, guess what? 0. All right? So that makes conceptual sense. But what I want to do is unpack the mathematical formula that I typed in here. Now, this is really important that you go through this and do this on your own in your own worksheet. Don't just copy and paste the formula. So what we're doing in the first part of the formula, I'll see if I can kind of point this out. Okay, in the first part of the formula, we're taking the pressure and dividing it by 760 so we make it atmospheres. Now, what's this dollar sign business? Okay, eventually we're going to use a function called fill down, where it'll take this formula and go down to the next cell and the next cell and the next cell, so do all the calculations for you. You only have to set this up once. The dollar sign in front of the B and dollar sign in front of the 3, what that tells the spreadsheet to do is to take this value in cell B3 and hold it constant. So it doesn't go skip down to B4, skip down to B5 when we do the fill down function. So take the value of B3, hold it constant, divide by 760. That's the P in PV equals nRT. The V is the volume. Well, the ideal gas equation uses liters. So we have to take the volume and we have to divide it by 1,000. Well, that's what we do. The second part of the formula takes the D2, and we do want that value to change. We want to go to D3, D4, D5, divide by 1,000. Now we have to pay attention to the numerator and denominator. Check out all those parentheses. I put parentheses around the P. I put parentheses around the V. The asterisk is times. If you don't put the times, it doesn't assume it's multiplication. And then I put parentheses around the whole numerator. So there's 1, 2, 3 sets of parentheses for the PV term of PV equals nRT. In the denominator, we're doing R times temperature. Now, I think I cheated a little bit here. So R is 0.08206. That's fine. You just type that in. That's not a data point. That's just a constant. So I didn't put that on the spreadsheet. And we're multiplying by temperature, which I think I did cheat a little bit. I just took 273.15 and added 20 and put it in there directly. We could have changed that to a dollar sign formula, but you don't have to do that. So here's what you do. You type that in and you get the first value. Then you click on it, highlight down as far as you want to go, and then come over here and use the fill down function, and it will complete all of the data for you. And we're going to use that function every single time along the way. Okay, I'm going to kind of sprint a little bit through some of this because it's going to get a little long. All right. The next step, I'm not too worried about this, is the next column is calculating the moles of hydrochloric acid that are lost as this reaction takes place. And this will make maybe more sense later. So what are we doing here? These next 3 columns go together. So how much hydrochloric acid is consumed, how much hydrochloric acid is present, and then we subtract those 2, I think, sort of. Oh, no, then we convert into a molarity, sorry. So we go from moles to molarity. But again, just follow along. So here's the deal. I mentioned before about the 1-to-2 ratio. So every time we produce H2, we lose 2 moles of hydrochloric acid. So in this next column, I'm taking, you have to put an equal sign, by the way, mathematical formula. I'm taking the moles of hydrogen gas in E2 and multiplying it by 2, fill down. Next column, here's the deal. How many moles of HCl are present in the flask? Okay, well, here, this one's a little different. So the first column is basically the molarity times the volume. What? Okay, so we took 6 milliliters, go back to your data. We took 6 milliliters, which is 0.006 liters, and we multiply it by a molarity of 1. Molarity times volume equals moles. So before this reaction even starts, so what is it, times 0? Well, there's, what is that, 6 times 10 to the minus third moles present. Just the solution itself, molarity times volume. Skip down to this one. Then what we're doing is we're taking the value that's there to start with. So $G, $2. So we're taking this data from the same column, which is kind of weird. But that's the number of moles of HCl that start out with. Again, I'm not concerned that you remember all of this. And then we go from there. So what we do then is take the moles and then subtract off, okay, the moles of HCl that are lost. So that would be F3. Yeah, F3. So the moles that started minus the moles of HCl lost minus F3, fill down. And if you look at that, all that does is takes the G to the first value and then bumps down the other ones, F12. If you don't follow all this, it's okay. Just repeat it in your column. Then what we do is we turn every one of those moles that remain, moles that are present from column G, into a molarity. Moles divided by total volume, and the total volume is 0.045 liters, 45 milliliters. So we take each of those moles and divide by the volume. So you set up the formula once, do the fill down. Whew, that's a lot. Okay, I'm gonna kind of just, since I don't have to tell you how to make graphs anymore, is there are 3 graphs you want to make. Time versus concentration of HCl remaining. So this column on the column C will always be the x-axis. The first graph is the HCl remaining just by itself. So what I did is I took, just to make my spreadsheet a little nicer, I took the times and I took the HCl's, I copy and pasted them down here. So we have time, we have the, so I just, that's all it is, just copy and paste, and then I made the graph. I hacked out all the dead space, made it look nice and neat, axis labels, so reproduce that. I actually got the slope of the line, which may or may not make any sense, because it doesn't look too linear to me, but we'll figure that out later. And then I did this thing down here called the correlation coefficient. Now this is another mathematical formula. So here's correlation coefficient. You put the left parenthesis, you grab, I think it is, you grab the X data first, the Y data second. In this case, it doesn't really matter. And that gives you a number that is a measure of how linear the function is. The closer it is to 1, either plus or minus 1 in this case, because it's a negative slope, the more linear it is. So if you've used correlation coefficient before, that's fine. Okay, so quickly. The next graph, there's 3 graphs. So I copy and pasted the times because that data stays the same. Same idea of forms of slope, same idea of R. But in this case, what I want to do is, oh, I forgot I did this, is I want to take the natural log. So you're going to type in equal sign and take the natural log of every one of the concentrations. I'm going to let you figure that out. I think what I actually did in this spreadsheet was I did, whoa, hey. I think I did all the calculations. Yeah, I did all the calculations over here, and then I copy and pasted. And I actually copy and pasted the values, not the formulas. I'm going to let you kind of figure that out. So yeah, I'll come over here and do this. So here are my times. When you graph the concentration, so you'll learn about this later, that's called the 0th order analysis. When you graph the natural log, that's called the 1st order analysis. When you graph the reciprocal molarity, that's called the 2nd order analysis. So here's what I did all the calculations over here. So what I wanted to do for the natural log is equal sign ln. You have to put a parentheses, and then you want to take the natural log of each one of these concentrations and put those here. And the natural log of anything less than 1 is negative. So those are all negative numbers. The next thing you want to do is take the reciprocal of the concentrations. In this case, you don't have to put parentheses. You just put equal sign 1 divided by K, whatever, K3, and then do fill down, and it does all those for you. Always check these calculations by hand. Then what I did was I did all the calculations up here, and the spreadsheet, I didn't want it spreading too much left to right, so I copied the data in different chunks and then pasted them here. The problem is when you do the pasting here, make sure you choose paste special so it preserves the numbers. If it pastes the formula, it'll get all screwed up. So you want it to just paste the values by itself. I'll let you figure that out. So then you make that graph, concentration and time. Make the graph look nice. Natural log of concentration and time. Make it look nice. That one's a little trickier because you have a negative y-axis, so it looks a little sloppy. You might figure out how to get this down here. I think students figured that out last year, rather than have the x-axis across the top. So I didn't do a perfect job there. And then reciprocal versus time. Okay, that's probably enough of a tutorial. I think we're good to go. So you repeat all of what I have here. Maybe make it look a little nicer. Repeat that here and then answer some questions, I think, and we are set. So we can stop the share. And I believe we can stop the recording. All right. So do all of that, the review problems and all the spreadsheet problems before your first lab meeting. And you can see me during my office hours if you have me for lab, or see your lab instructor for assistance. They may have ways that they want you to do these specifically, but that's enough of a tutorial, should get you going. There's also some good tutorials online. Microsoft has a good support. So if you're like, I don't know what you're talking about, Dr. Shane, you can do a search and probably find some tutorials on your own. But the main thing is you want to be good with spreadsheets to make your life more efficient, more professional, and we will use these spreadsheets all throughout the semester. So it's not just a front end of the semester skill. So nice work. Let us know if you have any questions, and we will see you in lab or online or in class.